Question number 16. A foundation supporting two columns of building are shown in the following figures. Okay, so this is a figure here. We have the 2-watt column with a foundation on the ground. An extensive soil investigation was not carried out, and it was assumed in the design of the footing that the clay layer has a uniform thickness of 1.2, same as what we have here. 2 years after construction, the building settled with a differential settlement. Okay, this is a big problem. Wall of the building began to crack. A subsequent soil investigation showed that the thickness of the clay layer was not uniform, but varies as shown in the following figures. Yes, blue here, blue footing B, we have 2.8 meters, while here we have 1.2 meters. Okay, the owner would like to get an estimate of the expected total differential settlement. Okay, so we must be very clever here in solving these questions, because someone might say, okay, let me calculate the settlement under footing A and then the settlement under footing B and see what is the difference in the settlement, and will be the differential settlement. I mean settlement B, A minus settlement B, or settlement B minus settlement A, and get the difference, okay? But if you want to save some time, so we can say, if we are looking for the differential settlement, so easily we can say that the settlement due to this 1.2 meters, okay, under footings A is similar to the settlement under footing B. So, okay, what we want to do now is only to calculate the settlement due to this difference in the thickness. So now, what is the thickness of the this layer now? Is about 1.6 meters. Okay, so let us calculate the settlement under footing B for what? For this clay layer, which has thickness of what? 1.6. Okay, so what we have? We have the footing, which is 1.5 by 1.5. And definitely we want to calculate the settlement at the center of the footing, because this is the worst case scenario. And we know that if we have surface loading, and this is rectangular loaded area, okay, what we have here is 0.75 and here 0.75. Okay, so we can have these quarters here, and we get what is the stress, okay, due to this what? Footing, okay, at different depths here. Okay, so what we want to do, maybe we need to what? To subdivide this layer to sublayer. We might divide it to maybe 4 sublayers like that. Okay, so every one will be 0.4 meters. Okay, so we want to determine what? The increase in the stress due to this surface loading at this point for layer 1 or sublayer 1, sublayer 2, 3 and 4. So now we know here for this one what will be the depth from the ground surface. It will be 1.4 plus 0.4 divided by 2. It will be what? It will be 1.6. Okay, what about the second one? The second one here is 1.4 plus 0.4 plus 0.2. Okay, so it will be 2 meters, and so on for here and here. So this will be the Z. Okay, and you still remember, okay, that we have this what? Influence factor chart. So you should determine what we call it M and N, and you know it is what? It is the width of the length divided by Z. So divided by Z. For every sublayer we have different Z. we can get different m and n. Okay, so you come here and you said what is the n, what is the m, and you get the influence factor. Once you get the influence factor, you multiply this by the q. What is the q that we have here? The q that we have here will be this, what? 780 divided by the area, which is 1.5 times 1.5. Okay, so this is our Q. So now we can get what? We can get the increase in the stresses due to the surface load for the sublayer 1, 2, and 3, and 4. Okay, so we can have a small table like that, and we can say, okay, this is now sublayer 1, sublayer 2, sublayer 3, sublayer 4. Perfect. We know what is N, we know what is M. Okay, we know here this is L or B. Okay, so you can get it. Go to the chart above and get what? And get the influence factor. And when you get the influence factor, we can get after that the increase in the vertical stress for every layer. So we can get this value. Okay, then we can calculate the settlement for each what? Sublayer. How? We said it is mv times what? Times h. What is h here? Which is the thickness of each sublayer, which is 0.4. Okay, times what? Times the change in the effective stress. So we get the settlement for layer 1, 2, 3, 4. Then going to get here, we are going to get after that the total settlement. But don't forget to multiply it by 4. Why we multiply it by 4? Because remember, what we have before here is only a quarter of the loaded area. So if we want to get the total settlement, it must be multiplied by 4. So this is the 4 that we have here to consider this point. Thank you very much.